In today's video, we are going to get started with a new playlist that is Basic Electrical Engineering, which is in short called as BEE, and in some colleges they also call it as BEE as well. So I used to have this subject in my second year first semester. So when I have the subject, I was like, why do we have the subject, and why they have included this for CSE students? So I did not like so much, but still, we have to, since they have included, we have to clear. But it was a bit difficulty to many of my friends. So, and even so many outside also, so many people will say BW is hard, BEE is hard. So that is why I just want to make it easier for you. I'll try to simplify it for you in my own way and make sure that you will be writing well in the exam. Okay, so in this video, chapter 1, which is DC circuits, we are going to learn basic electrical circuit elements. So we have 3 elements. So what are those 3 elements we will be learning in this video? So those 3 elements are, first of all, you know what is DC, right? DC, AC. DC is nothing but direct current. AC means alternating current. So DC is direct current, and in this we have 3 elements, 3 circuital elements we are having: resistance, inductance, capacitance. Resistance is denoted by R, inductance by L, and capacitance by C. Okay, now let us see about each of them. First, resistance. Resistance is nothing but it is a property of a conductor, or you can take any material also, but that has to be a conductor. What do you mean by a conductor? Anything which allows the passage of electricity. Conductors, semiconductors, insulators, right? Insulator will not at all allow electricity. Semiconductors will partially allow, and conductors, they will allow the passage of the electricity through them. Okay, so it is nothing but it is a property of a conductor which opposes the flow of current or electrons through it. See, in some books I have seen it as current, in some books I have seen it as electrons. So simply, when a current is passing in a conductor, okay, the flow of that current or electrons will be opposed with the help of a resistance. Okay, so usually resistance, this is a symbol before symbol unit. The unit of resistance is ohms, and it is denoted in this way, and the symbol is, we will be having like this, speed breakers. Okay, so this is resistance, and the current P is nothing but the potential difference. Okay, next, what is the formula to calculate the resistance then? From Ohm's law, V is equal to IR. So what is Ohm's law? I'll explain you. So basically, Ohm's law is nothing but potential difference across a conductor will be directly proportional to the current flowing through it, and when you remove this proportionality, you'll be getting the constant, which is nothing but the resistance. Okay, so about Ohm's law and about the working problems, some example problems of Ohm's law, I'll do it separately, but for time being, you just remember Ohm's law is nothing but V is equal to IR. You already learned about in your engineering, in your 10th grade also. For me, in Narayana, I guess I learned it in 7th or 8th grade. I don't even know what is conductor, what is resistance, nothing I know in that age. But okay, so when you send this I over to this side, it becomes divided by, and R is equal to V by I. Okay, and we also have another formula. So when you are taking a conductor, so if you are assuming a conductor, then R is directly proportional to length of the conductor. Resistance is directly proportional to the length of the conductor, and it is inversely proportional to the area of cross section of the conductor. Got it? So from both 1 and 2 equations, what you can say, by combining both 1 and 2, you can say that R is directly proportional to L by A. Right? So whenever you remove the proportionality, whenever you are making it as is equal to, you will be getting a constant. Right? So that constant is nothing but rho here. So R is equal to rho into L by A, where rho is called as the resistivity, and the unit of rho is ohm meters. Okay, so R is directly proportional to the length of the conductor, and it is inversely proportional to the area of cross section of the conductor. So if you are combining these 2 equations, you will be getting a R is directly proportional to L by A, and on removing this proportionality, you will be getting the constant. That constant is nothing but the resistivity. Okay, and we have another formula also. Basically, this formula is to calculate the power. Okay, so power formula is V into I. In all the 3 cases, in case of capacitance, in case of inductance also, the formula for power is P is equal to V into I. Now, what is V? IR. So V is equal to IR from Ohm's law. And what is I? Current as it is, you're keeping it. IR into I square R. P is equal to I square R. So when you're given current and resistance, you can find out power in this way. Okay, so for everything, for resistance, for inductance, for capacitance, for everything in the exam, if you are asked to explain about the electrical circuit elements, first you have to write the definition. Okay, next unit, symbol, and fourth is formula, fifth is power equation, and sixth phasor diagram. Okay, all these things, 6 things you have to write for each resistance, inductance, and capacitance in the exam if you're asked this question. Okay, next phasor diagram for resistance. So the place was not enough in the previous page, that is why I've drawn it here. See, voltage and I both will overlap with each other. Sorry, potential difference and the current both will overlap with each other. Okay, no lag or no lead. Theta is equal to 0 degrees. No lag. What is lag, what is lead, you will understand next. In the inductance and capacitance, you will understand what you mean by lag and what you mean by lead. Okay, now second circuital element is inductance. Inductance is usually represented with the symbol L. Okay, so what do you mean by inductance? The property of a conductor which opposes any change in the magnitude or direction of current passing through the material. Don't get confused. See, whenever you're confused with a definition, come in the reverse direction. If you're not able to understand, then nobody can do anything. So current passing through the material, any changes which are happening to the magnitude or direction of the current passing through the material. See, current is a vector quantity or a scalar quantity. Okay, keeping that aside, basically magnitude or direction, in terms of magnitude or in terms of direction. In terms of magnitude, in the sense, suppose if the value of current is 3 amperes and it has changed to 6 amperes, the value has changed, right? This is change in magnitude. Change in direction is nothing but if the current is flowing in this direction, suddenly it got changed to in this direction, or it got changed to this direction, whichever. So if the direction or the magnitude of current is changing, then that changes should not happen. Who is responsible for that? Who will take care of that? Conductor. The conductor will inductance. So inductance is a property which will oppose the changes which are happening in the conductor. Changes related to what? Current. It could be in magnitude wise or it could be in direction wise. So these two changes will be opposed with the help of the inductance property. Okay, done. Next, what is the unit? Henry. It is denoted by H, and symbol is like this, coil. Okay, next, V is equal to L into di by dt. This is the formula we have. So for inductance, next, power is equal to VI. You already know that. What is V here? L into di by dt into I. So P is equal to, you're bringing this I over the side, L I di by dt. Di by dt is nothing but the change in current. So here, as we said, changes in the current. So that change in current is di by dt. Okay, and the unit of current power is watt, so we have written it as watt. And here also you can write V, like voltage. But if I write V, again you will get confused, right? Again one more V. So I've not written. Now let us go to the phasor diagram. So in phasor diagram, this is the potential difference and this is the current. Okay, potential difference, current. Now the angle between the current and the potential difference is 90 degrees. So we have written theta is equal to 90 degrees. Now, which is leading, which is lagging? Leading in the sense which is above, which is up. See, leading means what? Lagging means what? It has a lot of physics theory involved in it. But for time being, I'm telling you, which is on the top, voltage is on the top, right? So from here to here, 90 degrees, and which is in the top of 90 degrees? Voltage. So that is why voltage is leading the current by 90 degrees. Got it? Voltage is leading the current by 90 degrees. This is about the inductance phasor diagram. Simple. Inductance is nothing but it is a property of the conductor which will oppose the changes which are happening to the magnitude or direction of the current in the conductor. Got it? And unit is Henry and the symbol is this coil kind of thing, and the formula for power and phasor diagram all. Now let us move to the next thing, that is the capacitance. So capacitance also simple. Let me check if I have missed any points in inductance. No. Now let us check capacitance. It is the property of material to store electric charge within it. It's simple. It is the property of the material to store the electric charge within it, and the unit of capacitance is farad, F-A-R-A-D, farad. It is denoted by F. Okay, and the symbol is this one. See, don't get confused with the symbol of battery. Battery will have one line big and one line small. This is battery, but capacitance, two lines, both positive and negative terminals, will be equal in length. Okay, that is the difference between the capacitor and the battery. Okay, don't get confused. So this is the symbol of capacitance. Next formula, C is equal to Q by V, or we have other formula like I is equal to C D VC by dt. Or see, if you're getting confused between inductance and capacitance, simple, their voltage will play, here current will play. So here we have I is equal to C into dVC by dt, right? What was our formula there in inductance? Just reverse the terms. I will become V, C is L, d I by t, right? So you're just replacing the terms, that's all, nothing. Current and voltage are being replaced. Any one you remember and you replace the things. Okay, next, power is equal to VI, same. So in VI, you know I here, so V into C dVC by dt, VC dVC by dt watts power. Okay, next, the phasor diagram for capacitance. So basically for capacitance, phasor diagram will be in this way. Voltage will be in the bottom direction, which means again theta is equal to 90 only here also, but the voltage will lag the current by 90 degrees. There voltage was leading, right? Simple, you can remember, in inductance voltage was leading, and the formula also V is equal to, and in capacitance you have I is equal to. So you are not having voltage here, right? So that is why voltage is lagging like that. Okay, that's your wish, how you remember. So this is I and V graph, and the angle will be 90 degrees. Since voltage is down, it is lagging the current by 90 degrees. Okay, this is all about this video, guys. In the next video, I'll explain about the voltage and current sources. This is my first video in VW. So if you are having any, if you're not able to understand at any point, if you want me to make any changes, let me know. I'll definitely try to make it. So thanks for watching the video till the end, and if you're still having any doubts, let me know in the comment section. I'll be more than happy. I'll be very happy to clear all your doubts. So thanks for watching the video till the end. Let's meet up in the next coming video, and also let me know whether you want me to continue this series or not.